Hello everybody, my name is Arnya Kantrat. So today I'm here with another video of the subject mathematics. So today's topic is about the half-range Fourier series. So let us look into the contents. So first, you're going to study about what is basically a half-range Fourier series. Second is about half-range odd function Fourier series. And the third is about the half-range even function Fourier series. And fourth, you're going to look into a problem, which is basically an example for the half-range Fourier series. So what is basically a half-year Fourier series? So it's nothing but a function which is defined over half the range, say maybe from 0 to L, instead of the full range from minus L to L. It may be expanded in a series of sine terms only or of cos terms only. So the series produced is then called a half-range Fourier series. So basically there are two types of functions, half-range even function and half-range odd functions when it comes to the number system function. So basically let's look into the half-range even function. In the half-range even function, it can be expanded using its range from 0 to L or minus L to 0 or L to 2L. So that is nothing but the range of the integration is L. The Fourier series of the half-range even function is given by the formula which is mentioned here. F of t is equal to a naught by 2 plus summation from n is equals to 1 to x into a n into cos of n pi t by L for all the values of n from 1 to 3 to so on, where a naught is equal to 2 by n integration from 0 to 1 f of t into dt, and a n is equals to 2 by L into integration from 0 to L f of t into cos of n pi t by L into dt, and b of n is 0. Now let us look into the graphical representation of the half-range even series. So n is in the figure below. It's shown as the graph for f of t. That's nothing but the function of t, which is equals to t. It is sketched from 0 to t is equals to pi. That's nothing but the integration which ranges from 0 to pi. So the graph is shown here in the pictorial representation. And next we are looking at the even function, which means that it must be symmetrical about the f of t, that is nothing but the function axis, and it is shown in the following figure by the broken line between t is equal to minus pi and t is equals to 0. So you can see here, it's nothing but touching the origin at 0. So it's the graph of f of t. It's illustrating an even function. So it can be also assumed that the triangular waveform produced is periodic with periodic 2 pi outside of the range, and it is shown by the dotted lines. Here it's showing that it's a triangular waveform which is being periodic actually. So from pi it varies to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi, 4 pi to 5 pi. It starts either from minus pi or a positive value on the graph. So let us look into a basic example here. The question is given as f of t is equal to integration from minus t to t. If minus pi is less than or equal to t, which is less than 0, or t if 0 is less than or equal to t, less than or equal to pi. So, and now fetch f of t is periodic with period 2 pi. Here, let's sketch the function for the 3 cycles and then find the Fourier trigonometric series of f of t using the half-range series. So basically, this is the same function which we saw in the illustration example. So we can plot the required graph as graph of f of t, which is a triangular waveform which varies in a periodic manner, as I told you in the previous few minutes ago. That's nothing but it might range from minus pi to pi, pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi, and so on, until unless the relation between pi and t is specified. Now let's look into the second question, which says that we need to find the four trigonometric series for f of t using the half-range Fourier series. Since the function is even, we have b of n is 0. Okay. So now let's look at the example where L is equals to pi. According to the formula, it's like a of 0 is equal to 2 by L into integration from 0 to L f of t dt. Now, differentiating or integrating with respect to dt, we get it as 2 by pi integration from 0 to pi t to dt. So integration of t is t square by 2. So basically 2 by pi into t square by 2. Substituting the upper limit and the lower limit, you're going to get the value as 2 by pi into pi square by 2, which is nothing but pi, and pi square gets cancelled, 2 and 2 gets cancelled, the remaining one variable is pi. Now, sorry, it's a constant. Okay. So now to find a n, we use a result from the before. That's nothing but in order to refer to the integrals, you can go for the formula book or you might have it in your mind set before. Okay. So now the integration is from t cos nt dt, which is equal to 1 by n square into cos nt plus nt sin nt. We also have the formula as a naught is equal to 2 by L into integration from 0 to L f of t into cos of n pi t by L into dt. Now, on simplification, we get the second step as 2 by pi into integration from 0 to pi t into cos nt dt, which is equal to 2 by pi into 1 by n square into cos nt plus nt nt. Now, next step we can see here as 2 by pi n squared into cos of n pi plus 0 minus cos of 0 plus 0, which is the above formula which we have referred in the third step. After that, we can look here. Then we get the formula as 2 by pi squared into cos of n pi minus 1, which is nothing but minus 1 to the power n minus 1. So when n is odd, the last line given is minus 1 by n, which is nothing but taken as power to the above term. So for the series, we need to generate odd values of n. We need to use 2n minus 1 for n is equal to 1, 2, 3, and so on. So on using that formula, you get it as a naught by 2 into summation n minus 1 to n, a naught into cos of n by t by L. You get the above answer as pi by 2 is equals to 1 by pi into cos t minus 1 by 9 cos 3L minus 1 by 25 cos pi t. So that's the answer for the above required question. So let's move on to the next section. Half-range odd function. So what is basically a half-range odd function? An odd function can be expanded using half its range from 0 to L, that is the range of the integration it has a value L. So the Fourier series of the odd function is as follows. Since a0 is 0 and an is 0, that's nothing but we have the formula as f of t is equals to summation from n is equals to 1 to infinity b of n into sine n by t by L for n is equals to 1, 2, 3, and so on. Whereas Bn in the sum is given as 2 by L into integration from 0 to L f of t into sine of n by t by L into dt. So in the figure below, f of t is equal to t. It is sketched as shown here in the graphical representation. It's nothing but any value of t for the function above mentioned in like the formula which is mentioned here. You can get the value as t itself. So that regarding that, when you input the formulas using the values of 1, 2, 3, and so on, you're going to get the graph as such, which is plotted here. It's nothing but the range is from 0 less than or less than t less than or equal to pi. So from t is equal to 0 to t is equals to pi, here it is shown. Now let's look into the further graphs. So an odd function means that it is symmetrical about the origin, and this is shown by the red broken lines between t is equals to minus pi and t is equals to 0. Here in the blue broken lines it is shown that it varies from minus pi to t is equals to 0. An odd function also means that it is symmetrical about the origin, and it shows by the blue broken lines between t is equals to minus pi and t is equals to 0. So it can be interchanged from 0 to minus pi or minus pi to 0. It's going to show the same odd function. So it's also assumed that The waveform produced is periodic of the period 2 pi outside of the range as shown by the dotted lines. So here you can observe the graph, how it is varying from minus pi to 5 pi with the variance of f of t and t in the respective x and y axis. So it's nothing but the graph of f of t, a periodic odd function. So thank you for watching my video. If you like this video, please give it a like, share, subscribe, and stay tuned for more videos. Thank you so much.